Good morning to Alpha. Can you hear my voice?
Yes.
Okay. Okay. Very good. So I will present you. I will try to share my screen. Present now your entire screen. Okay. Okay. Now, class, can you see my screen sharing?
Can.
Okay. Can also. Okay. Very good. Everyone is okay today? I hope okay now. All right. Are you ready for the today lesson? I can't hear you. Okay. Never mind. All right. So I think we can start now. Yeah. Last lesson, I asked you to try to finish exercise on your workbook, page 81, right? Page 81 to 80, 82. All right, 81 and 82. Okay. So any problem, or do you need to discuss the question on page 81 and 82?
Yes.
You need to discuss it, right? Okay, never mind. So you can open your workbook, page 81. So we try to discuss the answer right now, right? So I hope you can see my presentation as well. Can you see my presentation? 7.5, yeah? Experiment, the inquiry experiment 7.5, 7.5, page 81. All right. So this is the experiment how to measure electric current and voltage here. Okay. Before I start, I need to explain to you one thing first. Yeah. Okay. Where is it? Media. All right. So there are two diagrams. Yeah. You must understand the electrical diagram first. Okay. Where is it? Where's the symbol? Oh, okay, never mind. All right. So, can you see the display over here? Can you see the diagram, the picture? All right. So we have here two type of diagram here, right? The first is what we call a picture diagram. Okay. Diagram A over here. Diagram A. Okay. Diagram A over here. Okay. Diagram A. And then diagram B. This is what we call by picture diagram. So slow lah the internet, I don't know how. Okay, this is picture diagram. Because why I call it picture diagram? Because it clearly show you how to connect the component on an electrical circuit. Okay, for example, this is the real picture of bulb. This is the real picture of emitter. Okay, this is bulb, and then this is emitter, and then this is the dry cell, and then switch. All right. Represent, okay, the picture diagram. We call it a picture diagram. Picture diagram or pictorial diagram show you the exact look of the component. All right. For example, we have bulb, emitter, switch, and dry cell, and then it is connected by what we call here connecting wire. Connecting or just we call it wire. Okay, just connect it with wire. So this is picture diagram. Easier for you to see lah. Okay, if the electrical circuit is not complicated, so we can just use what we call picture diagram. Okay, and then B also we call it picture diagram. Represent what? It represent the real component, the real shape, the real component of the electrical component. Electrical component, we use picture diagram over here. Okay, and then down here we have what we call by. This is what we call schematic diagram. Okay, see here, see here, we call it schematic diagram. Okay, this is schematic diagram. Consists of what? Consists of line and then electrical symbol. Okay, we try to learn later on. We're going to learn the electrical symbol on the schematic diagram. Okay, for example here, for example, the battery here. Let's wait for a second. Okay, class. I am very, very sorry. I have important call to take. Yeah. Are you still there, class? Can you see my presentation? Can we continue?
Yes.
Yes.
Okay, I'm very, very sorry. Okay, I need to answer very important call. Okay, so we continue, right? Okay, where do we continue? Okay, schematic diagram, and then this is what we call schematic diagram. Refer to the same things. Refer to the same things, but only the simpler, what we call simpler, what we call easier for us to understand.
Sorry,
This is
teacher.
yes,
Teacher, can you discuss page 81?
81. Okay, never mind, never mind. I just want to explain this first, and then I will continue to discuss page 81 because I take the picture also. I take the picture. This picture is also from the workbook, page 81 and 82. Okay, this is also from the
Okay.
workbook, right? Okay, very simple, very simple. I will be very quick over here. So schematic diagram, before you can answer page 81 and 82, schematic diagram is using symbol. For example, here, I will go very fast here. This one, this is the symbol for bulb. Okay, and then this is the symbol for emitter. All right, so, and then the connecting wire represent by the line here. Connecting wire represent by the line here. Okay, can you understand this? And then for another, for example, this one also, bulb here represent by this symbol. Okay, voltmeter represent by this symbol. All right, it is the same thing. The difference is the different in diagram only. The diagram different. Okay, can you understand this? I hope you can understand which one is the what we call schematic diagram and the picture diagram. Okay, right. So we can continue page 81 discussion. Okay. What happened here? Right. So page 81. So how do you want to read the emitter and voltmeter? Okay. For example, if you can see my screen sharing right now, this is an example of emitter. Okay, this is emitter. All right. Can you see the picture? Just wait for a moment. A bit. All right, this one. This is an example of emitter. Okay, this is analog emitter. Okay, and then how we want to make sure it is an emitter? Emitter, we have A here, the what we call the A symbol here. The A symbol here meaning that it is an emitter. Okay, and then it consists of needle. We have needle here, needle, and then the needle is pointed to the value on the scale here. This is the scale for value. Okay, depending on the type of emitter. Okay, for example, this is the emitter that range from the 0 to 1.0 ampere. Okay, can you see here, class? Because it has 0, and then 0.2, and then 0.4 until 1 ampere. So this is the example of ammeter. And then at the ammeter, we have two terminal. This is what we call a terminal. Okay, this is terminal. This is what we call a negative terminal. And then this is positive terminal. And then this terminal connected to the what we call wire lah. We have the wire here or the cable here, connected to the cable. And then please make sure if you want to connect the terminal, or negative terminal, you just connect it to the negative terminal on the battery, for example. positive terminal, you connect it with a positive terminal on the battery. For example, if we have the battery here, if I have the battery here, usually the battery has positive and negative terminal. So you must connect it correctly. Okay, positive terminal, you go to the positive side, and then negative terminal, you go to negative side of the battery. Can you see the picture here? Okay, my question is, class, what happen if you what we call it, incorrectly connect the terminal? You reverse the terminal. Okay, for example, positive terminal, you go to the negative one, and then the negative terminal, you connect the wire to the positive one. What happened? Any idea what happened if you connect it wrongly? You just reverse the polarity, you reverse the terminal. What happened to the reading of the emitter? Any idea what happened?
The reading not accurate.
The reading is not accurate, right? Yes, of course, the reading is become not accurate. Why? Because if the reading normal, right, the needles over here will deflect from left to right. It will move this direction. Okay, if the connection is correct. Okay, from 0, it will go to 0.2 or 0.4 depending on the current of the battery. Okay, if you connect it, if you wrongly connect negative and positive with emitter, the needle will go what? The needles will go reverse. It will go down here. It will go down. Okay, maybe the needle will be in this side. Okay, it will go reverse. Can you understand me? Can if you, so how to correct it? Make sure you connect the wire from negative terminal on the emitter. You connect it to the negative terminal on the battery. Positive terminal on the emitter. You connect it with the positive terminal on the battery, so that the needle, the reading, the needle will go up from left to right, and then you're able to see the and able to take the reading correctly. Okay, I'll continue. Okay. Okay, can you see the reading here? What is the reading, class? Anybody? We have connected to AA battery. So what is the reading now? Make sure you're able to read the emitter reading, yeah? Okay. Can somebody tell me what is the reading of the current to battery? What's the reading? I think you can see it clearly, because on my handphone also I can see it clearly. So what is the reading of the emitter? What is the reading of the current?
0.24.
Current, okay, wait. Current ampere is 0. What ampere? Anybody? This is 0, and then this is 0.1, 0.2, this is 0.3. So 0. What is the reading, you think? Anybody? 0.24. Okay, this is 2, right? This one is 2, and then 6, 2, 4, 6, and then this is 8. Right, so it is about 0.2, 22 or 24, you think? About 0.22 or 0.24. Okay, is it correct? Can you understand this? Make sure you know how to take the reading, because we are using the analog emitter. Analog emitter using the scale and then using the needle here. So this is about 0.24 or 0.2, also 0.22, 0.24 or 0.22 ampere. A meaning, A is what we call by ampere. All right. So if you use the digital one, very accurate lah, yeah? But never mind. The digital one is later, but this is how you read the emitter. Okay, this is how you take the reading of current. Yeah? Current is A. The unit, the symbol is A. The capital A, not the small a. Remember. Okay. Can you understand this? So this is 0.24 A. So what I need you to do, you open your textbook, open your workbook, page 81, and then for emitter reading here, you just write here 0.2. Okay, not 0.5. Yeah, according to the answer from my workbook 0.5. But I need you to do some correction over here. Okay, you just write here 0.24 ampere. Huh? 0.24 ampere. Okay, 0.24 ampere according to the picture I already show you just now. Is it okay? Just write 0.24. Okay. Okay, class? Is it good?
Yes.
Okay. Because why? I take the reading from this video. Okay, I take the reading from this video. Right? So this is 0.24 ampere. Good? Right. So the next one, what is the reading of voltmeter? Okay, the reading of voltmeter. Voltmeter are still the same. Still the same. This is the what we call the the picture of voltmeter. The only difference is voltmeter, the unit here is V. The unit here is V. And then for ammeter, the unit is A. And then we have small underline under the unit. All right? So, right now, what is the reading of the voltmeter? Right now, this is the needle, all the same lah. This is the needle, all right? This is the needle, and then this is the scale over here, all right? And then this one is about 2 point what? 2.1 volt. Okay, this is 2.1 volt. Right? Very simple, right? Okay, never mind. Okay, this example, class, this is about, what is the reading of this, the voltmeter right now? Already got the answer here, right? It is about 1.05 volt. If the needle here is about in the middle between 0.1, okay, so you just write half lah, 1.05 volt. Okay, so you go back to the workbook here. Oh, sorry. All right, you go back to the workbook here. So what is the reading for voltmeter? Voltmeter, you just write 1.5 volt also. Sorry, 1.5 volt. So again, for ammeter, you just write 0.24 MA, and then for voltmeter, you just write the given answer, 1.5 volt. Sorry, not 1.5 volt. Okay, sorry, okay, class, again, I'm sorry again. Not 1.5 here, not 1.5. If you look at the picture above, okay, again, if you look at the picture above, how many battery they are. Okay, please look here. I'm sorry, please look here. Okay, dry cell here, it has how many battery? How many battery?
2.
2, right? This is battery number 1, and then this is dry cell number 1, and then dry cell number 2. Okay, usually dry cell, single dry cell is, what is the value? 1 point, sorry, it is 1.5 volt. You remember the picture I showed yesterday? One battery is about 1.5 volt actually. It is 1.5 volt actually. So if you has two battery, if you have two batteries, so 1.5 plus 1.5 volt, it will become 3.0 volt. Okay. How do you know the battery is 1.5? It's also 1.5. You remember the yesterday picture? There is the voltage of the battery is state on the label at the label of the battery, 1.5 volt. Okay. Still remember the picture? We call here. Okay. Dry cell voltage label info. For example here, I give you one example of the battery here. Can you see? This is battery, right? This is AAA battery. This is AAA battery. And then you can see here, there is a value given here. Can you see here? 1.5 volt over here. Okay. Usually battery got what we can know the voltage of the battery by reading at the label at the battery itself. Okay. So you can put here 1.3 volt. Okay. You can put here 3 volt. Okay. Ammeter 0.24 MA, and then for voltage you just write 3.0 volt. Okay, next one. Is it okay? All right. Okay. Thank you. So next one. Okay. Very easy, this one. I already explained this just now. Which terminal of the dry cell is positive terminal of an ammeter? Of course, like I said earlier, if you have positive terminal on the ammeter, must connect to the positive terminal on the battery. So you write the answer, the positive terminal. Okay, I already explained you just now, right? Okay, question number 2. State the function of the ammeter and voltmeter. Very easy. Ammeter to measure electric current, voltmeter to measure voltage. Okay, can you get it? Is it okay? Can I continue to the next pages?
Can. Yes.
Okay, thank you very much. Next one, question number 3. State the unit and symbol. I think I already explained this to you. Ampere, the electric current unit is ampere, and then the symbol is A. Big A, capital A. And then for the voltage, the unit is volt, and then the symbol is V, capital V, not small v. Okay, next one, number 4. Identify the type of electrical symbol and state the arrangement of the measuring tool in the electrical symbol. Okay, I think this may be, okay. So, the electrical symbol we will learn later, but never mind, I will explain to you now. Actually, it is 7 next topic, but at least you know the symbol. At least you know what is the symbol, All right. Okay. So this is the symbol of ammeter. A. Inside the circle, we have a big letter A here, meaning that this is the symbol of emitter. And then here, this is the symbol of bulb, B-U-L-B. And then this one, this is the symbol of what class? Oh, very slow lah. Is it okay? Okay. This is the
Yeah.
symbol of what? This is the symbol of battery.
Battery.
Battery or the dry cell. Okay. If you can see the symbol of battery, I will zoom a bit. I will try to zoom it first, to see more clearly. Okay. Right. All right. So if you can see here, there is a longer line and a shorter line. This is also longer line and shorter line. So in this symbol, how many battery you think? How many dry cell?
2.
Okay. This we have 2 dry cell. Okay. And then the shorter one, the longer one is positive or negative, you think?
Positive.
Okay, very easy. The longer one is negative terminal, and then the shorter line here is the negative terminal. Okay, so if I try to draw another symbol of dry cell like this, okay, how many battery? How many dry cell?
3.
3 dry cell. Good. We have 3 dry cell, and then which one is negative? On the left, on the right? Negative.
Left.
Negative on the left because it has shorter line here. Shorter line usually negative, and then if they have a longer line over here, meaning it has positive. Okay, very easy. Now, this is an emitter, and then how the component arranged in series. The arrangement of the component in series. Okay, what's the mean by in series? Series mean, okay, the connection of all the component is one loop. For example here, from positive to negative terminal, you just connect the wire in single loop. From positive, you enter the positive terminal on the emitter, and then exit the negative terminal on the emitter, and then go to the bulb, negative positive. Actually the bulb doesn't has any polarity. Wait. Okay, and then from the light bulb, go out, go to the negative terminal. So this is what we call a one loop. Okay, just from positive here, from positive go to negative. So this is just one loop. One loop, we call it a series circuit. Okay, this is what we call a series circuit. Series circuit. Is it okay? Can?
Okay.
Okay. Next one. All right, very good. The picture on the right over here. Okay, the picture on the right. Okay, this is the symbol of voltmeter. You have big circle, and then you connect it to the wire, and then inside we have V. This is voltmeter. Okay, and then it is connected by parallel. Parallel mean what? Parallel mean it has 2 loop over here, from positive terminal at the battery here to negative terminal. This is the first loop. Okay, this is the first loop. Can you see it? This is the first loop. And then where is the second loop? The second loop is from here to here. This is the second loop. Okay, second loop. And then This is the first loop. So we call it parallel. Okay, it just like the number 8 lah, just like a number 8. Just like the number 8 here. You just have one loop over here, and then another one here, the second loop. Okay, see, this is parallel circuit. And then they maybe in the circuit we have more than one loop. Maybe we have more than one loop. Maybe in the circuit there is a combination of series and parallel circuit. But this is the basic you need to understand between the parallel circuit and the series circuit. Is it okay, class?
Okay.
Okay, understand? All right, very good. So I continue. Okay, next one. Question number 5. Question number 5. A is voltage, and then do you still remember what is the charge moving inside a circuit? What is the charge moving inside the circuit? Positive charge or negative charge moving? Electron or proton moving? Here. What's the charge moving? Negative or positive? Can you see the symbol E over here? E mean what, class?
Electron.
Mean electron. Very good. Electron is positive or negative charge?
Negative.
Yes, very good. Yeah. So, electron is a negative charge. Negative charge that is moving inside a circuit, we call it current flow. There is a current. Electron move. When the electron move, we can say it carry the current, and then it has voltage also. Okay, you understand this, huh? All right, next one. So, what is voltage? Voltage is the electrical energy that move the electrical charges or electron from one point to another in a conductor. This is the meaning of voltage. The energy, the amount of energy need to move the electron. We call it voltage. Okay, the amount of energy need to move the electron. So we call it voltage. Right? Okay. So what is current? B is electric current. So electric current is the rate of flow of electrical charges or electron. The rate of flow of current, we call it electric current. Okay. Can you understand the difference between voltage and current? Okay. Again, what is voltage? Voltage is the energy that moves the electric charges. And then the current is the rate of flow of electrical charges. Okay, this is the difference between voltage and electric current. Voltage means how strong, okay, how strong it try to move the current. Right? Electric current is just the flow of electron. Just the flow of electron helped by the voltage to push it. You just remember this. You just remember like the water inside the pipe. Okay, I will try to find the video and then I will try to give you later. Okay, you just imagine the water inside the pipe. There is a current and then there is an energy that push the water. Energy that push the electrical charges, we call voltage. And then the charges inside the conductor or the charges inside the circuit, we call it current. The charges that move inside the wire, we call it current. And then the energy need to push the current, we call it voltage. Right? Okay, never mind. And then what is resistance? Okay, the resistance is the ability of the conductor to limit or to resist the current flow of current. Resist the flow of current. This is what we call resistance. Resist the flow of current. It will try to stop or slow down the flow of current. This is what we call resistance. Okay, so number one, conclusion: electric current measured by using ammeter, and then the unit is ampere, the symbol is big A, and then voltage measured by voltmeter, and then the unit is volt, and then the symbol is big V. Okay, you know why? You know why it used the capital letter A and B? Why you think? I think I already explained you last year of when you are Form 4. We have big A and then big V, capital letter. Because why? Because the unit over here is they take the they take the unit name from the scientist that discover it. Scientists that discover the unit. Okay, for example, volt. Okay, volt is from the guy's name Volta. Okay, I will try to find the information. I just forgot over here, right? Volta scientist. Alessandro Volta. The name is Alessandro Volta. They take the name from the people from this scientist over here, and then they use their name, and then they use it as a unit, Alessandro Volta. That's why you need to write in big A, not the small a. That's why you need to use big A, because it used this the scientist name here, Volta. Alessandro Volta. Okay. So how about ampere? Okay. And then for ampere, there is a guy named Andre Marie Ampere. Okay. Okay. So the guy here discover the current. So they take the unit of the ampere, named after the guy here, Andre Marie Ampere. That's why you need to write big capital letter of the unit, the symbol A and V. That's why you use big capital letter. Centimeter, for example, centimeter, Celsius, big letter or small letter? For example, meter. Class, we just do some revision here. Yes, meter, right? Meter is small, right? For me, meter. Because meter is not the name from people. So you just write big, little m. Celsius. It is not named from the meter. It is not the name from the people. You just write it capital, small letter only. Small letter. Okay? Right. All right. So I think I will stop from now. I will stop here. Okay, I hope you understand the discussion today. So I will continue. Wait, Okay. I will continue the topic, the relationship between current, voltage, and resistance next class. Okay. Next class is on tomorrow lah. Tomorrow I will start at 9:30, 9:15 in the morning tomorrow. Okay. Maybe you can read the topic first on your textbook page. page 150 and then to 152. You read the topic first, and then tomorrow we will learn the relationship between current, voltage, and resistance. Okay, class? Is it clear for you?
Okay.
Yes.
Okay, thank you very much. Um, okay, so we see you all tomorrow. I think today I will. There is no exercise for today. Tomorrow I will give you the exercise. Okay. So thank you very much for your attention and focus. I'll see you all tomorrow. Thank you very much. Bye bye. You can leave
Yes,
the class now.
teacher.
Bye
Thank you,
bye. Yeah.
teacher.
Thank you. Bye bye.
Bye.
Bye bye. See you all tomorrow.